Okay, let's talk about light for a little bit. So we know what light is. We know it's the stuff that enters our eye to allow us to see objects, but what actually is it? Well, light can be thought of as either a wave or a particle. We won't get to waves just yet. We'll get that in a few videos from now. We're just going to focus on the particle part. So the idea here is that light is actually made up of tiny little particles that are called photons. And photons, these little things that just travel in straight lines until they run into something else. And those straight lines, when light travels in straight lines, that's what we mean by a ray of light. So photons move as rays until they run into some other thing, which generally changes the direction of the photon, or what's happening to the photon. So what exactly is this stuff doing to the photon to change it? Well, if you look at the atomic scale, or if you look down to the size of atoms, here's a nucleus, and here's an orbiting electron. I'll make another one. Then what happens is the photon is traveling along merrily on its way, and it runs into this atom, and the electron gets excited. It absorbs the energy from the photon. Perhaps I should make that lighter orange to show that it's excited. So that electron runs around at a higher orbit with more energy and gets excited for a little bit before it finally relaxes. It relaxes and releases its energy again. Basically hiccups the energy it just gained back out as the original photon, which continues to travel in the same direction until it sees the next atom, which does the same thing. It absorbs the photon, it gets excited, the electron eventually relaxes back down and re-emits the photon. Now, this whole process of absorbing, getting excited, relaxing, and re-emitting the photon is basically just a form of delay that slows down the photon as it tries to get through a material. And that's really what it is about a material that light sees, or what changes how light behaves. And that thing that materials have to absorb and re-emit photons is called the index of refraction. Refraction. Let's get rid of that. Refraction. You might also see it called the refractive index. They're both the same thing, and they're generally written as in equations. So all materials have an index of refraction, and an index of refraction for materials almost always lies in the range of about 1 to say 5. And what this means in terms of the delay is that if you have a photon zipping along on its merry way with nothing out here, then it will just keep going in a straight line. And the speed at which it goes is what we call the speed of light in vacuum. And we generally write that as c. So anytime you see c, think speed of light in vacuum. And that is known to be 3 times 10 to the 8th meters per second. Well, it's not exactly 3 times 10 to the 8th, but it's pretty close. Close enough for almost any calculation. So if the photon then sees some material that it has passed through, then the way to determine its speed or velocity through the material is to take the speed of light in vacuum and divide by the index of refraction of that material. So the index of refraction of, say, air is 1, just like it is in vacuum. So the speed of light in air is just equal to c. And let's talk about water. It's always a good one, because its index is slightly higher, 1.33. So the velocity of water is c divided by 1.33, meaning that water actually absorbs the photon and takes a lot of time in order to re-emit the photon. And that delay causes the light to slow down when it enters the water. So that's really the big thing to take away from this, is that index of refraction is really just delay at the atomic scale. And that delay, the fact that atoms have to deal with incoming particles of light, is what gives us all the behavior that makes a photon change direction or slow down, and all sorts of things to come in subsequent videos.